We're going to move on and learn another rule for taking the derivative of composite functions. But before that, we're going to quickly review what composite functions are. And so a composite function is one way of combining functions for functions f and g. And we can define the composite function to be f of g at x is f of g of x. So let's just see what this looks like in an example. So let's say f of x is 2x minus 5, and let's say that g of x is x squared plus 3x. And I want to figure out the composite function f of g at x. So first, I'm going to just remind myself what f of x is. Then I'm going to put g of x into the x spot, just like I would substitute it in if it was anything else at all. Oops. After I've done that, then I can simplify. So that I have 2x squared plus 6x minus 5. And we can do this a variety of ways. We can also find g of f of x. So we will begin by reminding ourselves what g of x is. And then instead of x, we're going to put f of x into x's spot. And so f of x is 2x minus 5, and that needed to be squared. And I have that twice. In this case, now I'm going to simplify this further. So 2x minus 5 squared is 4x squared minus 20x plus 25 plus 6x minus 15. Combine my like terms, 4x squared minus 14x plus 10. And I can also, if I really wanted to, just find f at f. So f at x, if we remember, is 2x minus 5. So f at itself is 2, and instead of x, I'm writing what f is. And then I simplify. 4x minus 10 minus 5. And I can do the same thing for g of g if I wanted to. Okay, so a more likely question would be find the functions of f at x and g of x such that h of x is equal to the composite function f at g of x. So if h of x is all of this, what I need to do is I need to think about what could have been plunked in here in order to create this expression. Sometimes it'll be easier to find what could be plugged in, and sometimes it'll be easier to find what the parent function was. So in this case, I see that all of this is a group, and that could be g of x. And if that was g of x, that would mean that f of x was x to the power 4. And so if I were to create h of x as a composite function, then I would take f of x and plunk in g of x. Let's have a look at another example. So I'm looking for something that I can just simply replace. I can maybe just totally replace that denominator. So if I made that denominator g of x, then that would mean that f of x was just 2 over x, so that when I went to make h of x, I would have 2 over g of x. Okay, for practice, you're just going to do page 67. So this is back to the review. We're just backing up a bit. Just be sure to do 1 A, C, E, and G and question 2.